Geometry originating from ancient Greek words meaning earth measurement. It is the branch of mathematics concerned with the properties, relationships, and measurements of points, lines, angles, surface, and solids. Its roots trace back to ancient civilization, which is Egyptians and Babylonians, who used geometric principles for practical purpose, such as land surveying and construction. The formalization of geometry as mathematical discipline is credited to the ancient Greeks. Practically, Euclid, whose work defined geometry for centuries.
Over time, geometry has evolved through contributions from Islamic mathematicians during the Middle Ages. As for example, when we look at the buildings, the shapes and the structures we see are all part of geometry. This subject is not just a drawing, it also involves solving problems and understanding how different shapes relate to each other. In geometry, we learn about different types of shapes like triangles, circles, and squares, and how to measure their area and perimeters. We also explore three-dimensional shapes like cube and spheres. Understanding geometry helps us in everyday life, from designing buildings to creating and even in sport.
Chupa Chup is a famous lollipop brand that originated in Spain. It is known for its innovative design and iconic logo created by the artist Salvador Dali. Chupa Chup was founded in 1958 by Spanish entrepreneur Enrique Bernat, who envisioned a candy on a stick to solve the problem of children getting sticky hands while eating sweets. He envisioned a sweet mountain on a stick to solve this problem. His motto was, "It's like eating a candy with a fork," originally named Gold, as it resembled a small soccer ball on a stick. The product was later renamed Chupa Chup, derived from the Spanish word chupa, meaning to suck. In 1969, Enrique Bernat asked Salvador Dali, the famous surrealist artist, designed the brand iconic flower-shaped logo, which remains in use today. By the 1970s, Chupa Chup had expanded internationally, including Europe and Asia, reaching over 100 countries, becoming a global phenomenon by the 1980s and 1990s. The lollipop became a global sensation, even being consumed by astronauts in space. In 2006, the brand was acquired by Perfecti Van Melle, further solidifying its position as one of the most recognized candy brands worldwide. It also is one of the first candies to be consumed in outer space when taken by astronauts on a mission. Legacy of Chupa Chups remains a symbol of fun and innovation in the candy industry, offering a variety of flavor and product line while retaining its iconic design and identity. The brand is now owned by Perfecti Van Melle, one of the largest confectionery companies in the world.
Question 1a. Amira bought a Chupa Chups lollipop. A perfectly round lollipop is a sphere shape. She has a thought about the measurement of the lollipop since she learned about the application of geometry yesterday. The diagram shows a lollipop with a radius of 10 cm. Find the volume and surface area of a sphere. As the diagram shows, a lollipop with a radius 1.5 cm. So, we can calculate the volume of a sphere using a formula 4/3 pi r cube. So we can calculate 4/3 times 22/7 times 1.5 cube equal to 14.1429 centimeter cube. Next, we need to calculate the surface area of a sphere. As we know, the surface area formula is 4 pi r square. So we can calculate 4 times 22/7 times 1.5 square. And the answer is 28.2857 centimeter square. For question 1b, Amira took a bite and the lollipop had cut in half, which is hemisphere shape. Find the volume and surface area of the hemisphere. As we know, the formula volume of hemisphere is 1/2 times 4/3 pi r cube. So we can substitute the value, and the radius given is 1.5 centimeter, and we can get the answer of volume is 7.0714 centimeter cube. Next, we need to calculate the surface area of hemisphere using the formula area of circle plus 1/2 times surface area of sphere, which is pi r square plus 1/2 times 4 pi r square. So we can calculate 22/7 times 1.5 square plus 1/2 times 4 times 22/7 times 1.5 square. And we get the answer is 21.2143 centimeter square.
The Kaaba is the sacred building in Mecca, Saudi Arabia, and the holiest place in Islam. It is a cuboid-shaped structure covered with a black veil of silk and curtain called the kiswah. Muslims believe it was built by Prophet Ibrahim and his son Ismail as a house for worshipping Allah. The Kaaba is very special because Muslims face its direction when they pray, which is called Qibla. Every year, millions of Muslims visit it during the Hajj pilgrimage and walk around it, which is called Tawaf. It represents the unity of Muslims and their devotion to Allah.
As the given here, the height is 50 meter, the length is 12 meter, and the width is 10.5 meter. To find the volume, we need to multiply the B and H together, which is the B is base area and the H is height. First, we need to find the base area. We need to multiply the length and width together. As the given, the length is 12 meter and the width is 10.5 meter. We multiply both of that, and then we multiply again with the height, which is 15 meter. Now we got the answer, 1890 meter cube. After finding the volume, we need to find the surface area of the cuboid. There are two ways to find the surface area. First, the formula is sum of base areas plus with the sum of lateral face areas. For the base area, we need to multiply the length and width together, which is 12 multiplied with 10.5. Since in the cuboid, there are two bases, we need to multiply the base area with 2. And then, for the sum of the base areas, we get 252. After that, we find the lateral face area. In the cuboid, there are two pairs of lateral face. For the first pair, we need multiply the width and height together, which is 10.5 multiplied with 15. After multiply the both of the width and height together, we need to multiply it again with 2. We got the answer, 315. After that, we find the other pair of the letter face, which is we need to multiply the length and height. The length is 12 and we multiply it with the height, which is 15. Also, we need to multiply it with 2 since it is paired together. For the second pair of the letter face area, we get the answer 360. After that, we must plus both of the letter face area to get the sum of letter face areas. Lastly, we need to plus both of the sum of base areas and the sum of letter face areas. And we got the answer, which is 927 meter square. For the second way to find the surface area, we're using the formula of 2b plus pH. The B is stand for the base area and the P is stand for the perimeter of the base and the H is stand for height. First, we need to find the B, which is the base area. We must multiply the length and width. After we multiply both of them, we must multiply again with 2 since in the formula it is 2b. And we got the answer, which is 252. After that, we find the perimeter of the base. For the perimeter of the base, we must multiply the length with 2 and then we plus with the width that have been multiplied with 2. After that, after we get the perimeter, we multiply it with height, which is 15, and we get the answer, 675. Lastly, we add together the 2b and pH, and we get the answer, 927 meters square.
In the first case, the application of geometry, specifically surface area and volume formulas for solid geometry, ensured precise sizing and portioning of lollipops and guided the selection of appropriately sized of it. This shows that the importance of geometry in the confectionery industry, providing essential tools for practical and efficient production practice. In the second case, the principles of geometry, particularly the calculation of volume and surface area in solid geometry, were applied to determine precise measurements for the prism, which is in this context was a cuboid. This approach demonstrated how fundamental geometric concepts can be effectively utilized not only to ensure accurate dimensions but also to aid in designing and constructing structures that are both stable and visually appealing. The application of these concepts underscores the importance of geometry as a critical tool in bridging mathematical theory with practical real-world engineering as architectural solution. The application of this concept underscores the importance of geometry as a critical tool in bridging mathematical theory with practical real-world engineering and architectural solutions.